All right, folks, we're going to do the FRQ on your study guide. FRQ 1 is calculator allow, so make sure you got the College Board decimal out. Let's go. Let f be a function defined by all real numbers. So over here, your table is a function f. The table gives a value f of x at such a value. Sorry, I don't have the whole screen out. Such the value of x. The function g is defined by over here. So you got the two things going on. There's a f, there's a g. The function h is defined by h of x is equal to f of g of f of x is equal to g of f of x. Find the value of h of 5. I know you can't see, so I apologize. So we're looking for h of 5. So what does that mean? That means you're going to take that 5, plug it into where the x's are. So I like to look at this one over here, the compositional function. This is the same as g of f of 5. So when functions are combined together, where do you start with it? You always start from the inside. So I'm going to start with f of 5. Which one is f again? Is that the table or the function? Equation of the function is the table. So when input is a 5, output value is going to be 3. So this is 3 right there. Now you go next, which is g of 3. What is g? Right here. Two ways you can do it. You can actually take that 3 and then plug it into x over here to evaluate it. However, since I have a calculator, I'm just going to use my calculator. Don't sweat it, right? So let's go. On the line number 1, I'm going to type my function g. G of x is equal to 2 natural log of x minus 2 plus 4. And as you can see, there is your logarithmic graph. And under line number 2, since my decimal know what g of x is now, I can just ask what is g of 3. Answer is 4. I'm going to say this is 4. Done. I don't have to round up anything. There it is. You could have plugged in over here, as I said, and if you wanted to do it without using your decimal, let me just show you. That's what I got. What is natural log of 1? So e to the what power is 1? Any number to the 0 power is a 1. So this is 0, folks. So 2 times 0 is 0 plus 4. That's why you got 4. Either way, you get the same answer. Number 2, find all values such that f of x, the table, is equal to 1. Be careful over here. The mistake you're going to make is mixing up the input and output. So that when you're given 1, is this 1 the input or output? That is your output. So we are looking for the input when output is 1. Look at your table. When your output is a 1, what's your input? 4. 4. I know the question didn't ask you, but another way of saying this was f of inverse of 1. Right, the inverse. Just bonus question. Bonus knowledge. Letter B, find all value of x as decimal. Okay, so that tells me I probably want to use my calculator. Such that g of x is equal to 1. Which one is g of x? This one right here. Which I already typed it on my decimal. What g of x is. I just told the decimal what that is. Underneath it though, I'm going to erase that g of 3 because I don't need that anymore. And then I'm literally going to say now, tell me where g of x is equal to 1. This means, folks, the y value is a 1. As you can see, the blue line, the y value is a 1. So on a red line, where do I have a y value of a 1? You can kind of trace it if you want to, but then really, I'm going to zoom in. Right here, isn't this point the y value is a 1? So when y value is a 1, what's the x value? 2.223. The thousands or more, or you can say 2.2231, 2.2213, all of those are fine. Be careful over here. Should I use that as an answer too? No, don't. But there's a dot there. I don't care. There's a gray dot because that's an x-intercept. But the problem did not ask you to find the x-intercept. The problem is asking you the intersection between the g of x and g of x is equal to 1. So only use this one right here. X is equal to 2.223. Okay? I'm going to erase everything. Okay? Let's keep going. Letter B, number 2, determine the end behavior of g as x increases the bound. Express your answer using the mathematical notation of a limit. Okay, so I'm going to type it. When you use the limit notation, there are 4 things going on, folks. Please write LIM. Underneath it, you're going to tell me where x is going. It says as x increase. So think about it. X is getting bigger. So where are we going? X is going to go to positive infinity. Name of the function, it's a g, so g of x is equal to, now you're going to tell me where y is going. I'm going to zoom out, zoom out, zoom out. As you go to the right, what y value is going to? I know it looks like it's like getting less steeper, but really it's going to keep going, up, 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 up. So it's going to go all the way to positive infinity. Letter C, based on the table of the value, oh, I have to go back. Is it going to be a linear what does this say? Linear, quadratic, exponential, logarithmic. And underneath it, we're going to give a reason why what we said what it was, based on the relationship between the change in the output value of f and the change of the input value of f. Refer to the values in the table in your reasoning. Okay, so bear with me as I flip back and forth. I'm going to go up. So this is the table that we're studying right here. So you're going to tell me what kind of function that is. Let's check what's going on. All right, so my top row is my input value. What do you notice? I notice that inputs are increasing by 1, plus 1, plus 1, plus 1. What do you notice about output? How do you go from 1 over 27 to 1 over 9? 1 over 9 to 1 over 3. Or easy yet, 1 to 3. Shouldn't you all just multiply by 3? Which makes sense. This is when inputs are additive, your outputs are multiplicative. What kind of function is that, folks? That is your exponential function. So answer for C1, I'm just going to say exponential function. C2 says give a reasoning. So I will say over the equal length input interval value, right? Because my x is increased by 1. My outputs are proportional. And that proportion is you multiply by 3. So did I talk about the relationship between the change of the input and change of the output? Yes, I did. And did I talk about the values over here? Yes, I did. Okay, so don't forget to talk both about how inputs are increasing over the equal length interval value, how outputs are proportional, which is proportion by a factor of 3. If you just say over the equal length interval value, my outputs are proportional, you're not going to get a full point. Why not? Because you didn't talk about how that's times by 3. So make sure you mention at what value they're proportional. Okay? All right. So there's that, FRQ1. I'm gonna see how much time is left in this. You're gonna tell me 7 minutes? Okay. I want to do this. I'm gonna make another video so I don't go over 15 minutes. All right, so FRQ2, I'll do in the next video.